All right, let's dive into one of the biggest and most powerful ideas in all of Python, classes and objects. Now, this is more than just a way to write code. It's a whole new way of thinking that lets you model the real world right inside your programs, making everything way more organized, intuitive, and best of all, reusable.
So let me ask you something. Think about your own projects. When you've got a whole bunch of related info, like a user's name, email and age, or a product's price, stock, and description, how do you keep all that stuff together? Can turn into a real mess real fast. I mean, sure, you could try using simple lists like you see on the left there. But look at that. You have separate lists for names, IDs, departments. It's a nightmare to keep track of. What if you add a new employee and forget one of the lists? The whole thing breaks. Now look at the right. That's the dream, right? Each employee is this neat, self-contained little package, an object, with everything clearly labeled. That's where we're headed.
So how do we get from that chaos on the left to that beautiful order on the right? The answer is the class. And honestly, the absolute best way to think about a class is as a blueprint. It's not the actual building, but it's the detailed plan that tells you exactly how to build it. A class is that template. It defines what every object made from it should have. For example, a blueprint for a car would say that every car needs a color and a speed. It also defines what that car can do, the actions, like accelerate or brake. It bundles all that data and all that functionality into one tidy package.
And here's the best part. You might think this sounds super complicated, but getting started is incredibly simple. Look at this. In Python, this is a totally valid basic class, just one line. It's an empty shell, sure, but it's a starting point. It's not nearly as intimidating as it sounds, is it?
Okay, so if the class is the blueprint, what's the actual house you live in? Well, that's the object. An object, which is also called an instance, is the real thing you build from the class blueprint. It's filled with actual real data. You don't live in the blueprint, you live in the house, which is an instance of that plan. And this right here is us actually building from that blueprint. We're taking our dog class and we're using it to create a specific real dog object. We'll call him Miles. This whole process, this act of creating a real object from a class, has a fancy name, instantiation.
So we get it. A class is the plan, an object is the result. But how does that actually happen? How does Python take our blueprint and breathe life into it, creating unique objects every time? Let's look under the hood.
The magic really happens inside a special function called __init. You're going to see these methods with double underscores, we call them dunder methods, all over Python. Think of __init as the factory assembly line. It's the constructor. It runs automatically every single time you create a new object.
Okay, this is so cool because it really breaks down what's happening behind the scenes, especially with that mysterious self parameter. So when you type miles equals dog, miles4, Python kicks into gear. First, it sees you want to build a dog. Second, it automatically calls that __init method for you. Third, and this is the key, it creates a brand new empty object in memory and passes it into init as that very first argument, self. Finally, the code inside init uses that self to start attaching the data. It says, okay, for this specific object, let's set its name to Miles and its age to 4. So self is just a placeholder for the object that's being born.
Now this brings up a really important distinction. You've got two kinds of data. Instance variables, like a dog's name, are unique to each specific object. My dog Miles is different from your dog Buddy. But then you have class variables, like species. These are shared by every single object made from that blueprint. So every dog we create from our dog class will automatically have the species Canis familiaris. It's a shared fact. But objects are way more than just fancy containers for data. Our blueprints can also define actions, behaviors. This is how we teach our objects how to do things. In Python, we call these instance methods.
Here's the crucial thing to remember. A method is just a function that belongs to an object. It's part of the package. And because it belongs to the object, it has access to all of its data. So as you can see here, the speak method can use self.name to know which dog is speaking. An object's behavior is directly tied to its own unique state. And just when you think it can't get any cooler, it does. What if you need a new blueprint, but it's really just a more specialized version of one you already made? Well, you don't have to start over. This is where inheritance comes in, and it's a total game changer. Think of it like creating a family tree for your blueprints.
The idea itself is pretty simple.
You create a new child class that automatically inherits everything, all the data attributes and all the action methods, from a parent class. The child gets all of the parent's powers for free, right from the start.
And you won't believe how easy it is to do this in the code. It's this simple. When you define your new child class, you just put the parent class in parentheses right next to it. Just like that, our Jack Russell Terrier class is now a specialized kind of dog, and it can already do everything a normal dog can do.
But what if you want your specialized class to act a little differently? Well, a child class can provide its own version of a parent's method. We call this overriding. So here, our Jack Russell Terrier has its own speak method that's a bit more specific. It has a default sound of arf, replacing the more generic version it would have inherited from the dog class.
Sometimes, though, you don't want to completely throw away the parent's method. You just want to add a little something to it. That's what super is for. The super function is like a hotline to the parent's class. It lets you call the parent's version of the method from right inside the child's method. So you can run the original logic and then add your own special twist. You're extending, not just replacing.
So let's just quickly recap the whole journey. We started with the blueprint, the class. Then we used that blueprint to create real things, objects. We used the __ init constructor to set them up. We gave them behaviors with methods, and then we created whole families of blueprints using inheritance. That's the whole shebang, the full life cycle of object-oriented programming in Python.
And that really brings us to the end of our explainer. You now have the tools to create your own custom, organized, and powerful types in Python. You can bundle data and behavior together in a way that truly reflects the real world. So, the only question left is, now that you know how to create the blueprints, what are you going to build?